This is lesson 5.3. We are solving systems of linear equations using something called substitution. All right, so we learned how to solve them previously by graphing them. Today we're going to learn how to solve systems using this method called substitution. So let's take a look here at problem number 5, which is the first problem we're going to do today. I've got two equations. I've got y equals 2x minus 11, and I've got 4x plus 3y equals negative 13. Now don't forget, when we're done, here just to remind us, our solution, because this is a system of equations, okay, our solution is going to be an actual point. So we're going to have an x and we're going to have a y. Okay, so I've set myself up to remember that I'm talking about where these lines cross. It's a point on a graph, but we're solving today without a graph. We're using substitution. All right. The main idea behind today's lesson is understanding that if I have the statement that y is equal to 2x minus 11, that literally means that they are equivalent, that I can substitute one for the other. So take a look at what I'm going to write for this first section here. I'm going to say 4x plus 3, but I'm not going to write y, is equal to negative 13. So I've taken this equation, I've written it without the letter y. Now what I'm going to put in there is I'm going to put in there 2x minus 11, because we are told that y is equal to 2x minus 11. So in other words, instead of writing y, I'm going to write something y is equal to, and that is 2x minus 11. What this does is it gets our equation now so that we can actually solve it, right? It gets us down to only one variable in this equation. So it's kind of recall how this works. We're going to distribute the 3, so I get a plus 6x minus 33 is going to be equal to negative 13. My next step in solving is just like any other solvable problem here. We're going to have 10x minus 33 equals negative 13. Now we need to get rid of this 33. I'm going to add it to both sides. All right, we've started messing with both sides here. Some of us like to draw this line to separate. So now I've got 10x equals 20. And last but not least, we're going to divide out the 10. So I get my x value is 2. All right, now let's not forget, I only just found x. I still have to have y because I have to have an x and a y value for all of my solutions. So let's take a look. And if I want to find y, once you find the first one, just plug it in to find the second one. And that's true for this method and for the method we're going to talk about next. So if I already know, because they told me, didn't they, that y was equal to 2x minus 11, right? They gave me that equation. And I just figured out that x is, what? What did I just figure out that x is? Yeah, I just figured out that x was 2. So now to find y, all I have to do is simplify, right? 2 times 2 is 4 minus 11. So my y value is simply negative 7. All right, negative 7. And I've got my answer. All right, my solution is 2, negative 7. Now just a really quick way to check our answers here is to plug in our solution, 2, negative 7, into each of our equations. So right now I'm going to do this y equals 2x minus 11. So I'm saying that y is negative 7, right? So when I type in the next half, right, 2x minus 11, I should get negative 7. So I think x is 2 minus 11, should get negative 7, and I do. And you also have to check the second equation. So the left side of the equation, I'm plugging in x and y, so I've got 2 for x plus 3y, so plus 3 times negative 7. When I press enter, I should be getting negative 13, right, because that's what the left side is supposed to be equal to, and I do. So your solution works for both of your equations. The x and the y values make both equations true. All right, let's look at problem number 6. Problem number 6, instead of giving us y equals, this time they've given us x equals. And I probably should have mentioned that if you're going to use this method, you should always have either x equals or y equals. Because if you don't have that, there's probably an easier way to do it. So just keep that in mind. So let's look at problem number 6. This time, I've got x equals negative y plus 1. So because this is my x equals, this is the one I'm going to substitute. So let's start with that first one here. I have 5x, but I'm not going to write x, minus 9y equals negative 51, right? I'm not going to write x. I'm going to write something that's equal to x, the same as x. All right, so in my parentheses, instead of writing x, I'm going to write negative y plus 1. Right, again, because those are equal to each other, just like it says here. What this does for me, like I mentioned earlier, is now I just have y's to solve. So I can solve when I have one variable. We've got 5 times negative y, which is negative 5y. 5 times 1 is just plus 5. Minus 9y equals negative 51. My next step to solve, we want to simplify this left side. We're going to combine like terms. So we've really got negative 14y plus 5 equals negative 51. We're going to subtract 5 from both sides of the equation. So I've got negative 14y equals negative 56. Divide both sides by negative 14. We've got y equals, I don't know that one off the top of my head. Let's type that in my calculator. Negative 56 divided by negative 14. And I get 4. So y is equal to 4. Let's not forget, as we mentioned, that this solution to a system always has an x and a y. So be really careful because this time I found y, which means that this 4 goes in the second spot. It goes in the spot where y usually goes. So I found y, I still need to find x. So you can plug the 4 into either of the equations we were given, but I think this one is easier. All right, so I'm going to say x equals negative y plus 1. And I just figured out that I think y is 4 negative plus 1. So x is equal to negative 4 plus 1, which is negative 3. All right, so negative 3, 4. And again, you can always check that answer by plugging in the x and the y into your original equations. All right, I'm not going to do that right now just to save time. If you need another example, just go back in the video and watch that first one again. Okay, problem 7. Here we go, problem 7. Okay, this time I was given an x value again. So I'm going to start off by plugging this, right, 4y plus 5 in for x. So 7x minus 2y equals 35. Okay, but I know that x is actually 4y plus 5. Again, x is the same as 4y plus 5, so I get to plug that in. All right, here we go. 7 times 4y is 28y. 7 times 5 is 35. Minus 2y equals 35. Combine your like terms. We've got 26y plus 35 equals 35. Now you might have noticed that something is a little strange here. It doesn't happen super often, but I'm getting 26y equals 0. Okay, well, that doesn't mean no solution, right? We can actually still solve this. I'm going to divide by 26. And I've got y equals 0. And if you're not sure if you're allowed to do that, because I know some of us get confused with zeros, type it in your calculator. 0 divided by 26. Yeah, it's just 0. All right. So my solution, I've got the y value just figured out, right? We just figured out the y value was 0. So make sure it goes in the spot for y, and we're going to find the x value. All right. Again, I think this one's easier to plug stuff into. So we've got x equals 4y plus 5. And I just found out that y is 0, so I'm going to plug that in. A lot of you guys probably do this part in your head here. So we've got y equals 4 times 0 is 0 plus 5, so x equals 5. So my solution is 5, 0. All right. And problem number 8. Okay, in problem number 8, they have given me y equals again, just like problem 5. Okay, so I'm going to plug it in. I'm going to keep 8x plus 4. But I'm not going to write y this time equals 36, right? Because y is equal to 2x minus 9, right? Y is equal to 2x minus 9. So in my parentheses, instead of writing y, we're going to write negative 2x plus 9. All right, now we can solve. We've got 8x. We're going to distribute minus 8x, and plus 36 equals 36. We're going to combine our like terms, and wait a second. We're getting 0x plus 36 equals 36. Okay, well, I don't even need to write 0x, do I? That's kind of silly. So we've got the statement 36 equals 36. Okay, this is weird, right? Well, do we remember from a couple of lessons ago that a system can have a solution, just like all of our 3 answers we just did were solutions? But there's a possibility for no solutions. There's also the possibility for an infinite number of solutions. If you get something weird, it's either no solution or infinite solutions, right? We don't have an equation really anymore. We just have the statement 36 equals 36. Now, if it's weird but true, right, 36 does equal 36, we have got infinite solutions. All right, infinite solutions. So if we had ended up with a weird statement that was false, that would have been no solution. Okay, now just to confirm, because we never want to take these things for granted, right? Infinite solutions happen when our equations are identical. So I'm going to take 2 seconds and I'm going to convert this equation. Okay, just to prove to myself that, yeah, it's infinite solutions in this case. We've got 8x minus 4y equals 36. So if I solve and get y by itself so I can compare these real easily, what do I get? Let's see. I get y equals 9 minus 2x. Isn't this equation identical to this equation? Yeah, they're the same exact equations. Okay, I guess that makes sense for why this time I'm getting infinite solutions. I had the same equations to start with.